All right, let's work on section 1.3, solving equations with variables on both sides. So to solve an equation with variables on both sides, we use inverse operations to collect the variables all on one side and then the constant terms on the other. So we're basically taking all of the variables, putting them on one side of the equal sign, and taking all of the constant numbers and moving it to the other. It's called isolating the variable. Then we would solve that one or two-step equation from there, and then it would look a whole lot simpler. So looking at these examples, these look a little bit different than the ones we've been doing because we have here variables on both sides. I have 3k plus 45 equals 8k plus 25. Now, usually we'd be able to combine like terms and add the 3k and the 8k together, but these are not able to be added together because they are on opposite sides of the equal sign. You can only combine like terms if they are on the same side. If this said 3k plus 8k equals, 24 or something like that, we could add the 3k and the 8k together to be 11k equals 24, but we cannot do that if they're on opposite sides of the equal sign. Notice the equal sign is splitting this in half, and we have 8k's on the right and 3k's on the left. So here's what we do. To move them all to one side, we have to use inverse operations to move them around. So you have two options. You can either take the 3k and move it over here, or take the 8k and move it over here. Those are your two options. To do that, you would use inverse operations to move it. The opposite of a positive 3k is subtracting 3k. So here's one way to do it. You could subtract both sides by 3k, and 3k minus 3k cancels out. On the left-hand side, I'm left with 45. On the right-hand side, 8k minus 3k is 5k plus 25. So here's one way we could move it by subtracting 3k. I'll show you the other way after I solve the problem. Now, I'm going to solve this two-step equation. We have all of the variables together in one term right here. Now they're all, this is not x, sorry, this is k. So now they're all one single variable, 5k together. Now I'm going to start solving by subtracting 45 minus 25 to move the constant numbers, and that's going to become 20 is equal to 5k. The last thing I'm going to do is divide both sides by 5, and we're going to get our answer is 4. Now you can always take your answer and double check to make sure it works by replacing 4 in for the k's up top here and seeing if it actually does work out to be true, and it will. I'm going to erase all of this, and I'm going to show you the other way that you can solve it as well. So instead of moving the 3k, if I want to move this 8k right here, I would have to also use subtraction because it's a positive 8k. The only way we can cancel out positive 8k is by minusing 8k. If I do it this way, then on the right-hand side, I'm just left with a 25. On the left-hand side, I'm left with 3k minus 8k is negative 5k plus 45 equals 25. Now if I go to solve it this way, I would subtract both sides by 45. Notice the process looks a little bit different. I'm left with negative 5 times k is equal to negative 20. Now that I have it ready to go like this, I would divide both sides by negative 5. And again, the process looks different, but when I do that, I'm still going to get positive 4 as my final answer. And you could take 4 and put it in for both of these k's and do 3 times 4, which is 12. 12 plus 45 is 57. We could do 8 times 4, which is 32, plus 25 is 57. So we get the right answer for both. Looking at the next one, 5x minus 1 equals 7x plus 5. I'm going to move all of these variables to one side. So my options are to either move the 5x to the right or the 7x to the left. I'm going to move the 5x to the right, and the way I would do that is by subtracting both sides by 5x. When I do that, these 5x's go away, and be very careful. I'm left with a negative 1 on the left-hand side, and 7x minus 5x is 2x, plus 5 on the right-hand side. Now it's time for me to solve this two-step equation. I'll do that by subtracting both sides by 5. And negative 1 minus 5 is negative 6. So I get negative 6 is equal to 2x. I divide both sides by 2. And I get negative 3 is equal to x. Just be very careful with your negatives and making sure that you're understanding when numbers are going to be negative, what they're going to be positive, if you're going to divide, what your answer is going to be. At this point, we have calculators, so you should be able to lean on that just in case. If you're feeling confident, why don't you try and pause the video and try the second letter B. That should be letter C, but we can try this next one if you're feeling confident. If you're not quite confident, then let's do this one together. Letter C says 7 minus 5z equals 17 plus 5z. So what I'm going to do here is decide how I am going to move these variables around. You have two options. You can either move this negative 5z to the right, or you can move this positive 5z to the left. It's up to you. This 5z right here is a negative 5z. That minus sign is attached to that number. That's a minus 5z or a negative 5z. Let's move that to the right-hand side. To do that, I would add 5z, which is the opposite of minusing it. When I add 5z to both sides, those cancel out, and I'm left with 7 equals 17 plus 10z. Now this is a whole lot simpler. I would subtract both sides by 17. 7 minus 17 is negative 10. So I get negative 10 equals 10z. Dividing both sides by 10, I get negative 1 is equal to z. So my answer here is negative 1. Now there's two ways to solve each one of these, so if you prefer to solve it differently, instead of adding 5z to both sides, you could also subtract 5z and get the same answer. If now you're feeling confident, why don't you stop the video and try letter D on your own. All right, let's go over letter D, and let's realize that there's two ways to solve this problem. We can either move this over here or move this over here. You do that by doing the inverse operation of what's happening. If you want to move the minus 4x, we can add 4x to both sides. If you do that, you're left with 10 equals negative 9x plus 4x is negative 5x. And we would divide both sides by negative 5, and 10 divided by negative 5 is negative 2. That's one way to solve that problem. If I rewrite this problem again, 10 minus 4x equals negative 9x, there's also another way we can solve this. If you would like to solve it differently, you could also get rid of the minus or negative 9x by adding 9x to both sides. There's always two ways to solve these types of problems. When I do that, we're going to get 10 and a negative 4x plus 9x is a positive 5x. And on the right-hand side, negative 9x plus 9x just equals 0. Now we would move the constants all to the right to get them away from our variable. That means subtracting both sides by 10. I would get 5x equals negative 10. I would divide both sides by 5. And I'm still going to get negative 2 as my answer. So I'm just showing you a second way to solve, just so you can see that there's more than one way to solve these problems. All right, and then this last one is the most difficult from the whole page because we have to use the distributive property, and some of them are fractions, but it's okay. We will get through it. Letter E, I see I have to distribute here, and I have to distribute here. I have to multiply the numbers on the outside by all of the numbers on the inside. So, step 1, 3 times 3x is 9x. 3 times 4 is 12. This is going to be a minus 12. And then you're going to be using the fractions, and that's okay. 1/4 times 32x. You can do 1/4 times 32 in your calculator and get 8. And then it's going to become an 8x since that has a variable. And then 1/4 times 56 is 14. Now I'm left with variables on both sides. You can either move the 9x over here or the 8x over here. It's up to you. To do either way, you have to just do the opposite of what's happening to cancel out that variable. I'm going to move the 8x to the left, and I want to do that because when I subtract 8x from both sides, I'm going to be left with a positive number of x's, and I prefer to have positive numbers rather than negative. 9x minus 8x is just 1x, so I'm left with x minus 12 equals 14. Now this is just a one-step equation. I'm going to add 12 to both sides, and I'm left with x is equal to 26. And again, you can always check your answers by taking these numbers and replacing them in for the variables. So if we flip this over to the last page, we have here some practice problems, 4 practice problems, 1, 2, 3 here, and then a keystone practice problem. So 4 total problems that I would like you to try right now, and before we leave class today, we will go over those answers.